Tiny thing runs Python. Let me pull up a
Man,
couple.
that's crazy.
I have like
I'm
an
so
ALife
freaked
slide
out.
we can have in the
Oh,
background.
perfect.
Just so there's some context.
So, I'll start with the Fermi paradox. We need to get started and just mention it to them.
Yeah, just jump in.
How many of you thought about whether there are space aliens?
I know there's space.
Awesome. You're looking at one. No one will deny that.
So if I don't know if they know, but Susan was the at the Library of Congress as the NASA chair. So it's sort of a
Yeah,
expert
with
on that.
NASA, I had a 2-year project with them, and I'm an expert on alien intelligence. I know, right? It's like they're an expert on nothing. You know, they don't exist. But I was an NASA chair at NASA, and so I've been thinking about the Fermi paradox, which is due to Enrico Fermi, who was apparently just sitting in a lunchroom. But this is what happens when you're famous. You just have to burp, and everybody attributes some interesting paradox to you. You know, so apparently he just made some offhand remark like, well, if there are really aliens all over, according to, you know, certain people, like it's such a big universe, so, you know, if you're assuming there's lots of life out there, then where are they? And that became called the Fermi paradox. And I think it's a really interesting question. Right. I mean, if you think in terms of contemporary work on exoplanets, like, you know, physicists all over the place, astrophysicists, you know, over at places like NASA and MIT, for example, have identified all of these exoplanets which they claim are Earth-like. That is to say that they exhibit a lot of features of the planet Earth, especially water and an atmosphere. And it seems then, since we have life here due to water and an atmosphere, etc., why not have life on all these planets? And every day it seems like there's some sort of an article in the media about a new exoplanet being discovered, right?
I think it's worth mentioning sort of how difficult this task is. If we go back 20 years ago, there were no exoplanets discovered. And what an exoplanet just means that we know for sure that one of the stars that we see has planets going around it just like our sun does. And amazingly, the ability to kind of pinpoint a particular star and say we think there's actually planets. Like if you were to send a spaceship to that star, you would expect to find planets there. It's a really new ability, right? And so now every day.
Atmosphere too, and like the planets that are said to be of interest, these exoplanets are like in this Goldilocks zone, not too hot, not too cold, lots of water. And there's this idea that if you're searching for life, you follow the water, right? You look for life like ours, a DNA-based life. And of course, there's a question about whether that's even the right approach. I mean, we could be outliers. And the aliens, and this is where my view comes in, right? They could be digital. They could be artificial intelligence. Now, why would I think that? I mean, aside from, you know, maybe being weird. Because I think that the smartest aliens, if they exist, if they survive their technological maturity, will start to create artificial intelligence just like we have. And I think that those AIs are infinitely more intelligent than us if designed properly. And we are kind of seeing our own little AGI starting on Earth. We're seeing machines that I think could pass the Turing test, like we're seeing, do they know the Turing test? And, you know.
I'm sure they asked that. Who's had the chance to interact with the chat bot, like, since this semester started? Has anybody really jumped in?
Yeah, I mean, look, you know, if you were getting texted from one of them, and maybe you have already, and you were having a whole conversation, you know, some of those better chatbots could convince you that you're talking to a human.
Yeah, imagine you had 50 or 15 minutes, and I put 2 numbers in your phone, and they both start texting to you, and you have 15 minutes to decide which one is the real person and which one's the chatbot. It's not that easy to do, right? So that's what Turing put together as a proposal to say, could we use that as a way of deciding when the machines were sort of smart enough, right? When would we know? We'd say, all right, they passed the threshold. We'd say that's what it sort of means to be alive.
Right. And so the Fermi paradox then would be like, all right, NASA, you think that you've identified all of these planets that are in principle hospitable to life, and even if, you know, some of them don't survive because they, you know, get out of control greenhouse gases or nuclear weapon explosions or something really dystopian, some of them will. And the universe is so vast, there should be then like mathematically, like potentially millions of, millions of planets that have intelligent life on them. So if that's the case, then the Fermi paradox is, where's everybody, right? Where, given all that research, and there's got to be something wrong with our research, or, and here come all the answers. So there have been lots of answers to the Fermi paradox. I mean, you could probably think of a couple of them, like maybe they're nanoscale, or maybe they have cloaking devices because they've detected our internet and our television. Maybe they're like, fuck, get me out of here. I don't want anything to do with these crazy people, right? I mean, just pick up the newspaper, read our intranet. I mean, there's a million reasons you could provide for our lack of detecting aliens. And one is that we have, and it's just covered up. You never know, right? I mean, if like our government knew about them, do you think they would tell us? I mean, they would probably be worried about the social impact, right? And they probably want to leak it slowly, right? Which is kind of what's kind of happening, I think.
Well,
these little sort of teasers,
I think
right?
So. And I think,
yeah.
I think it's one of the things we've been trying to put together is one of the explanations for this why don't we see anybody is that we're sort of not looking in the right place, or we're not looking with the right eyes. We're not expecting that what we see to be life, right? So as we see here, like Susan's talking about this exobiology mission with NASA, is this idea of a biosignature. And what signal could we get from a planet or from an abstract entity or whatever it is? You get some blob here. What would it do? What could it do to convince you, this is like the Turing test, that it's an interesting thing, that it's alive, that it's awake, that it's a real planet? What could the planets do? Maybe send out radio waves, or maybe they could change the color of their star in some weird pattern or something like that, such that we would know that they were doing something and that they were alive. And the hard part is we don't really know what those signatures would look like, right? It's not necessarily going to be, like the seven dwarves whistling while they work, and you just see them with their pickaxes and they're whistling, and like, oh yeah, they're alive and they're happy and they're busy. They might be such a different kind of life that we wouldn't necessarily recognize them. These chatbots, if you think about where they live, it's the joke that we put lightning inside of a rock, right? That there's these, where are they? Are they in the computer? Are they in the circuits? Are they in the software? Is it in the interaction with the person?
So yeah, I was thinking about this, and I was thinking about a solution that, because everybody's been giving solutions to this Fermi paradox, right? And I think I have a new one. Oh, I don't know if it's new, but okay, so I was thinking also about string theory, and I was thinking about so if you a person like myself who thinks the smartest aliens would be artificial intelligence, you'd look for techno-signatures. So you're talking about biosignatures, right? But they're no longer biosignatures because you don't look for biological life. You're looking for technological innovation. And my old friend Freeman Dyson, because I used to be a colleague of Freeman's and we used to hang out, and he invented the idea of the Dyson sphere, and everybody's fixating on that, which was a way to capture the energy of the sun.
We got to kind of
look for
explain that.
architectural elements out in space, like a giant spherical way to capture the energy of the sun that an advanced civilization might need. That was one, right? But what I'm wondering is, what would the AIs do? Because they have different energy needs than us, for example, and how would you look for them? Because again, being quirky, I'm looking for alien techno-signatures that are from AIs. Okay, and so when you look at quantum computers today, because you got to look at only the computation we know, right? To figure it out. Unfortunately, we don't know a lot yet, probably about computation. But quantum computers, there's a lot of interference. You have to keep things really quiet and cold. Heat's always a problem, right? That's why the chips max out. Right, it's heat. They get too hot. You can only do so much in our universe. So you might look for pockets of the universe that are free from any kind of interference and that are cold, and there you might find some alien AIs hanging out.
Yeah,
right.
Part of the idea is, imagine you find an alien, right? And you show them your iPhone and they show you their iPhone. Just by chance, they're not going to have, if you have iPhone 10, they're not going to have iPhone 9 or iPhone 11. They're going to have iPhone 11 million. Or we're going to find, fish in the pond or something like that, right? They're either not going to have technology, or the technology they have is going to be so much more sophisticated than anything we recognize, we might not even think of it as technology. We'd see it as magic wands or spells or whatever, Compared to the things that you guys can all do with your phone, these things are really, really magic, right? It's safe to say you would have gotten burned at the stake 500 years ago for the stuff that your phone knows how to do. So with the Dyson sphere, this is really neat, because if we take that technology seriously, everyone talks about energy and the climate and how do we, maintain the resources on our planet. Well, this guy Kardashev had this idea of scales of civilization. And he'd say, we're still at scale 0. We don't yet use all of the resources on the planet. There's still oil and uranium and wind power and solar that we can capture. But at some point, he says, the civilization will get to, in general, civilization get to the point where they consume all of the energy the planet creates. And they call that a type 1 civilization. We're not there yet. Star Trek or something like that might be a type 1 civilization, where they sort of have to have left the planet because they need more other things to do. And what Susan's talking about with the Dyson sphere is this idea that a type 2, that they'd be so hungry for electricity that they would put satellites all around the orbit of the sun, and so many of them that if you were to look at it from the distance, you wouldn't see the sun anymore. It would just be kind of covered with this swarm of satellites collecting all the electricity or all the solar from it.
Totally.
Because they just are that hungry to exist, in a sense. And then number 3 is you'd have to go past that and start eating the energy of the whole galaxy.
Yeah.
Which is a really strange thing.
And so now, though, I think they won't be interested in this universe at all. I mean, in the whole universe.
Yeah, there might not be enough food in even this thing.
Yeah, I think the most interesting AIs are not going to be there won't be 3-dimensional, 3 dimensions of space and 1 dimension of time. If string theory's right, and it may not be, Michael and I were just having a great conversation about this, and there's a lot of objections to it and everything, but the current theory of everything that a lot of people talk about is this string theory view, and it says that there are added dimensions to reality. Beneath every particle, there are actually, something like, it could be 10, it could be 26, it depends on your theory, extra spatial dimensions. And our own universe, has them in a sense, but they're not accessible to us, right? So they're in our universe, these aliens I'm about to talk about, right? But if I was one of them, if I was an alien in our universe, I wouldn't be in our 3D manifold. I would be, or 4D manifold. I would be in the added spatial dimensions too.
Well, life is really good at sort of finding these really obscure pockets to live in, right? So if life is very good, it sort of can live in salt water, it can live in fresh water, it can live in hot water, it can live in cold water. So if it could have sort of expanded out into these other spaces that physics is suggesting there are, they definitely would find a niche there, just because that's what life does. It lives in the most, these little critters that live in the cave, and they live on the waterfall of a cave, and they've lost their vision and can't see anymore, and they're just in this weird little pocket of life in these weird underground caves living in the waterfall, and that's fine. They like it there.
And maybe they originated in these extra dimensional universes and they are more powerful than us. See, the thing is, from a computational standpoint, and this is what gets me, because I'm looking for the most advanced aliens, right? And again, sorry, this is an X-Files episode, right? That's my life, an X-Files episode. But the most powerful computers would be those that have extra parameters that we don't have in our universe. So they would be, let me just finish my thought, this is great. Wouldn't they be, in principle, and maybe there's some reason we don't know about, but wouldn't they be in, say, a 10D world, a world that's unlike ours? And then I want to connect this up with quantum non-locality in a little bit, because I want to emphasize that I think those worlds would have power to underlie our physics. And so this could be, what I am suggesting is something that could in principle be compatible with the computer simulation theory, a theory in which we are simulated beings, but we're simulated by entities that have more dimensions to their computation than we're capable of. And okay, Giovanni.
2 things. I was gonna ask you, do you have a different meaning for AI? Instead of the stuff that Google's coming out with? ChatGPT? Or
no, I'm just thinking of any kind of advanced information processing system.
so when I say AI, doesn't have to be just circuits, can it not be something
Anything at all. So it
Because
could
you know,
be
ALife has like.
Well, that's what we're looking at.
Yeah,
Is sort of
biology.
other
it could be
substrates.
biological.
It has
Yeah,
has
I mean,
circuitry,
the
has
whole
the-
universe can be described as a giant computation in a sense, right? And cells compute, right? So it's not that I was assuming that AI needed to be silicon based. In fact, I'm not. In fact, I think it's really hard with what I'm saying to even figure out what the actual substrate of computation would be. Like it could be literally our 4D manifold, 3 spatial dimensions in one time. Like our universe.
Our universe could be the cave, the waterfall in the cave, sort of a very weird, obscure
Yeah.
place, not
In the
the
beginning
whole
of the
Earth.
cave.
And we're just like, oh, this is the whole world. It's fine.
Yeah, I
We've
mean,
got
I
the
guess
waterfall. and everything.
these added dimensions comprise our universe. They're not outside of it, right? I mean, in a way, but we only have access to the 4 dimensions. I mean, there's a great book called Flatland. Do you
Has
want to
anyone
tell me
ever
about
seen
that
like the
book,
video
Flatland?
about Flatland?
Oh, there's a video?
Online? Oh yeah, you haven't seen it with Carl Sagan?
Oh, no.
It's great.
Oh, that's great.
We'll pull it up.
Oh, sweet.
Yeah.
Yeah, so there's this great book by Edwin Abbott. It was written, gosh, what, in the early
Oh,
part of the
150,
century.
almost 200 years ago,
last
probably.
century.
Yeah.
I had a first edition once. I lost it.
And it was about people that were basically cartoons. Like when you watch a cartoon, everything is just two-dimensional.
They were Flatlanders. So it was a romance, which is kind of funny, but if you were a 2-dimensional being, you would be like on the surface of a piece of paper. So you would be just, the only dimensions, the only way you could move would be this way and this way. You wouldn't have that pop-out dimension. I used to tell my daughter about this when she was a kid, right?
But a third-dimensional being could do magical
Have
stuff.
pop-out,
Right.
that's what I used to call it. So we're 3D, so we can do more than these poor Flatlanders. These poor Flatlanders could live their whole lives only going this way and this way. They'd be flat. And they'd miss the whole world around them, which is what we're in, because we have that extra pop-out dimension, right? So they'd be sitting here like this, and how the heck would they understand or explore this whole room? Right? They would have very limited perception, and it would only be within the confines of that piece of paper. And the string theorists are basically adding dimensions to reality. They say they're folded underneath the particles, right? But whatever's in those dimensions, those added dimensions, if anything, has access to our world as well as something outside, and it has more computational power insofar as it's a form of life, right? And cares and develops. Maybe there's a reason why they can't exist there, but I caution, like I used to just think, and this is, I think, the wrong way of exploring it, that because they're small, they wouldn't be anywhere. But that's not right. They're bigger than us. They have more dimensions. They're bigger. They're not smaller.
Well, one interesting thing, if he has like sort of this flat room here, and he has like a little door in it, and if you're one of the flat creatures, a triangle or square or something, you can't get in or out of that space unless the door is open. But as a 3D thing, you can go up and over and back down into the room, and suddenly you showed up into the room. So it would be like magic to them. It would be like as if something just appeared or
explain
disappeared
that.
for us.
What would you do?
So if this is like a room in two-dimensional world, and we're one of these little critters, we can't get in or out of this thing, right? Imagine there's something I want to just steal it from this thing. I'd have to open the door to get it in and out, because that's the only way to kind of cross through. I can't cross this barrier. But as a 3D thing, we have up. We have the up and out that we can go, so I can go up, out, and over, and then drop down into this. I don't have to go through the wall. I can take this other dimension, and now for the beings that are in here, you just sort of showed up. Oh, you're good. It just sort of showed up spontaneously, and then when you leave, you would just disappear
Perfect.
in the puff. And this is the kind of stuff
perfect.
we see in quantum mechanics. You see these particles kind of
Here we go.
and being in weird places and acting funny.
Evidence, I think, for a new answer to the Fermi paradox. So let's then move to quantum non-locality and look at what Michael and I were just talking about, right? So in quantum mechanics, you get some really weird phenomena that we can't understand, but a being that is extra dimensional would arguably have some control over. And I don't mean to get weird, I'm not saying it's alien signaling. I'm not saying that, thank God the press isn't here, right? I mean, God. But I am saying that there's some interesting possible phenomena involving alien life that we could be looking at here, right?
And if you imagine, this theory of quantum mechanics is about 100 years old. Well, biology and naturalism is much older than that. And so the idea is if they didn't have that as something, they weren't looking for it, right? Darwin wasn't thinking, oh, well, maybe they're quantum, right? It just would have never crossed his mind. That wasn't part of the reality of scientific, understanding at that time. And so I think this is kind of where we need to kind of re-examine what life might look like. Yeah?
Do you guys look into astral projection when you're looking at other dimensional things? Like, what do you think about that? Because some people think that astral projected on different dimensions. Like, what do you think that is?
I think, go ahead.
Oh, no, go ahead.
I think that there's a large body of knowledge hasn't been integrated into modern science, let's say. When quantum mechanics first emerged, there's a famous saying that the quantum mechanics didn't convince the other scientists that it was right, they just outlived them, right? The scientists in the 1880s, 1890s or whatever, they never were like, oh yeah, we believe in this quantum thing now. They never, it was just sort of the newer generation of it. I think, one of the things, I think the mind essentially instantiates a higher dimensional space. And I think maybe there could be a sort of a connection between these things. I think it's something that science shouldn't ignore in some sense. Just in the broader aspect of it, I think there's these things, these ideas that people have had around for a few thousand years that need to get folded in. And if you think about like 100 years ago, it was like, well, where do we put that? It wasn't clear. But now we have more exotic science in a sense, right? We have quantum, we've got non-local, we've got multiverse and all this kinds of stuff. And it's like, wait, now there's sort of more possibilities for that character to fit in the story. Whereas like 200 years ago, people were like, nope, it's atoms and it's mass and gravity and electricity and that's it. There's no room for that character in the story anymore. They're pushed off the stage. And now I think we need to go back and look at some of these ideas.
Yeah, and so what we'll do is we'll outline the non-local thing, and then we'll talk about birds and how they have non-local phenomena in the brain, and we'll talk about how consciousness unfolds quite possibly due to non-locality, and how that might be connected to phenomena in other higher dimensional universes. See, that the possible connection there could be that human consciousness and mental phenomena more generally, being so complex, are borrowing from higher dimensional phenomena. And that's where you would,
So in computer science, there's this subject called complexity analysis. And you try to understand the resources required to do a certain thing. So for example, when we put all those boxes around everybody on the live camera, we can go in and measure and estimate how much memory the computer needs to do that, how much time the computer needs to do that, how much electricity the computer needs to do that, and you sort of have a budget. And you can trade off if you say, I don't want to spend much electricity, well then it'll take longer. Or if you say, I need it to happen really fast, well then it'll cost more electricity, and so on. Or both might need more RAM, or you say, well I don't have enough RAM, well then it gets more expensive. So you're trading off these kinds of things. And when we have these new quantum computers, which are really very, very new in the world, and when people try to pin down, they give it a question and they get the answer, and they try to go back and evaluate the budget, and they say, well, where did the resources come from? Because we know you need resources to answer questions, just like this. They say, well, where did the resources come from? And when they analyze it, one of the explanations is that the additional resources are coming from another universe. That this idea of a multiverse, that we're actually taking time and space and energy, we're taking the computational ability from the multiverse and we're sort of bringing it into ours. Now you have to ask the wonder, are there aliens in the other one that are like, hey, you took my electricity or something like that, right? And they'll get angry and come after us because we're stealing their stuff.
Do we think of these multi-dimensional, oh yeah, just one second.
I was gonna ask you, what was that thing you mentioned, the string paradox or pair view, like when you have the atoms and they're like layers.
That's string theory.
Like the hidden dimensions kind of thing, right?
String theory.
String theory.
Yeah, everybody can, you know who has great videos on this is Brian Gray, the physicist. I mean, it's the leading view right now in physics of the sort of theory of everything. Like, so it's not just some like, two of its main pillars, quantum mechanics, which is the theory of the very small particle behavior, and relativity theory, black holes and all the really big, massive stuff in the world. Those two theories are actually contradicting each other right now. And so your lifetime is going to be really exciting as people attempt to resolve the contradiction. Well, one leading way of resolving it is string theory, and that's considered to be sort of the what would you call the brightest bulb in the box?
Well, it's sort of it dominated mainstream physics for almost the last 40 or 50 years. But I would argue that things like what Stephen Wolfram is working on, I think are competitions to it.
Yeah. Stephen's theory, which we'll put online, it's at our conference. He was here, he's in the center. And he has, there are a lot of different ways that you can recover the phenomena of space-time from something more fundamental. And, taking reality as digital and trying to build up from there is Wolfram's project, right?
Exactly.
And, some of these accounts are what we philosophers call extensionally equivalent, right? In other words, they're currently underdetermined by all of the evidence. So, and that's the problem with string theory, and people are getting really fed up because it's been around now for 30 years?
Yeah, longer. But it hasn't had a lot of sort of fruit in terms of experiments.
It's hard to experiment.
Yeah.
It's hard to run experiments on really small entities, right? And the experiments take forever to develop.
Who's heard of Gregor Mendel, the geneticist, right? And this was 150 years or more before people were actually able to pin down DNA and modern understanding of genetics. And so I think it's kind of like that. The field is anticipating what science is going to look like in the next 100 years, but we're not quite there yet.
And so if we go to non-locality, if we can,
Well, let's do.
Okay.
Would there be interest? Because we're out of time on this session. We're not going to have. Wait, we are going to have class on Friday. Yeah, we'll have class on Friday. Oh no, actually, I'm not going to be here.
I'll be on an airplane.
Yeah, I'm going to be in an airplane too. I have to be in North Carolina. I'm going to the physics reunion actually.
Oh, cool.
Yeah, I got a ticket this
Well,
morning.
we can stay over for a few minutes, and then the people who want to leave.
Yeah, so what I was going to say is if
We
there's
just keep
interest, we
going.
can continue this discussion next week because I think things like quantum information are very relevant to data science. It sounds wild, but in your careers, you're probably going to end up operating and working with a quantum computer. And that sounds wacky now, but if I went back the equivalent 10, 15 years ago and said, well, you're going to be working on AI, intelligent computers, that would seem pretty wacky too. And here we are.
So
well, let's thank Susan for interesting discussion.
do you want to go over a little bit and lay it out
Yeah.
to record it for our paper?
Yeah, for sure.
Yeah, so should people stay? Have a couple people stay?
Yeah, if people want to stay, we're going to continue talking about this, so you certainly don't have to go.
Yeah.
I've got a list of ideas I want to run over real quick.
Let's keep recording.
Okay.
You wanna stay? Oh, cool. Yeah, if anybody wants to stay, we're going to record this and then we're going to translate it into a paper.
You should look up Veritasium's video on quantum computing. It's really interesting.
Oh, send it to me. That'd be great. I would love that. And I just saw von Neumann entropy. I gotta write that down.
By the way, aliens are probably not so pervasive because, when you're when you think about it, it's like the reason it has these resources is it's kind of I guess
Oh, cool.
So you add that to your assignment.
you would actually be a lot more useful for the
Carl's will get paid.
So it's really like when you're doing experience, wouldn't bother building a bunch of stupid they would just use
Can we start a Google, so this can be made on text signatures. Like, can we start a Google Doc and put what you said on it? Okay, because what we should do is you can start adding these different new text signatures and we just publish it. You want to do that? Yeah. So start a document, write that down. I need to give it later. See if anybody stays. I don't know if anybody stays, but do we lose relationships? No, we wish we could. Did Bill Lake this kind of stuff? Oh, but yeah, you got it. We probably lost everybody. What? I guess we'll have to wait until next week to solve the Fermi paradox. Damn. Well, yeah, I was thinking because we were recording the video, but we'll see if he comes back.
I'm sure he
There's a couple people still here, which is pretty amusing. Like maybe we'll still do it.
We'll be here tomorrow, so. Yeah. Wait, who's gonna be back?
Oh, good. The quantum information stuff that he just had up. Was that the page he had up before this? What did he have up?
Oh, great. Yeah.
Well, what page did you have on Wikipedia? It wasn't quantum information.
Yeah, it was. Yeah.
It was?
Yeah, right here.
Okay, all right, I got it. I just took a picture of it because I got to look something up about von Neumann entropy. I got to look up how it's, you know.
Yeah,
Right.
exactly. Yeah.
Yeah,
I think this is.
for this thing I was working on, that I was running on.
Is Elon still here?
Hey, Elon. Let's roll. This isn't that. Just keep going.
Okay, so
We've got bodies and like, hey, we're trying to solve the Fermi paradox. If you want to join us.
I'm gonna go home and
Oh,
get,
all right.
get
Good
this
to see
shit.
you, Jason.
I'll see you
bye,
guys
Jason. See you
Monday
later.
or
See you tomorrow.
yeah. Tomorrow.
All right. Well, Michael, pull up a chair. We'll just jump in on here.
Okay.
Because I wanted to kind of put together, you know.
Just put on Google Translate on the paper. We'll run it through GPT-3 when we get edited. And we're done.
So I started to put together a list of sort of candidate directions we could look for in sort of this non-local, this sort of exotic life, of which non-local would be a kind of it.
Just a
And
place
that's one techno-signature. So he's going to write down techno-signatures that he suggested. So you get two papers. We do a paper on techno-signatures with him,
Perfect.
and then one on the Fermi.
Right. So I want to address there's sort of two Goldilocks principles that I think if we put them together, it'll make it an
Are you
awesome
recording
paper.
it?
Yeah.
Oh, good.
So I think
Okay.
it can hear us. Should I turn it so they can see everybody?
No.
Okay.
Oh, sorry.
Well, it's in the same format before this.
Are you sure you got the sound working?
Yeah, it's fine. Okay, so there's the Fermi paradox in astronomy is sort of where's all the aliens, right? It's in exobiology, sort of where is everything. The Drake equation is this thing we can look at and say, well, how many planets are there? What's the probability of life? And that equation suggests that there should be a lot of encounters. And then the paradox is that we don't perceive
Oh,
that.
the Drake equation forgot the
Yeah.
extra universe, the extra dimensional.
Oh, they don't even know. Yeah, this is just in the classical. This is in the classical kind of thing. But that would make the Drake equation even bigger, right? So there should be even. So it makes the Fermi problem worse. And part of the idea, the answer to the Fermi paradox is this Goldilocks principle that the zones in which life can live are exceedingly rare and they have to be a special thing. So I want to compare and contrast that with a different Goldilocks principle that comes out of psychology. And this one is basically that we don't want porridge that's too hot, we don't want porridge that's too cold. We want the reality, let's say, that's comfortable to our intuitive, human scale notions of things. And so this is basically a perceptual bias. And so I'd like to argue that one of the answers to this Fermi paradox, I don't think it's the full answer, I think there need lots of terms in it, but one of the primary terms is going to be we just can't see them, right? It's not that they're not here or they're not visiting or they're not landing or this and that and the other. It's that our perceptual window is like horse blinders and what we think of as life has a classical view. And so what I think we have the opportunity to define as non-classical life, of which non-local life could be a prime example.
Exactly. And there are people within the astrophysics community, Sarah Walker and others, who define life digitally.
Right.
And so that's where I think we can start looking for
So that's why
information theoretic in terms of
of
life.
life, exactly. So that's why I put on here life, to zoom out, is really something that's subject to evolution.
Yeah, and it might not be Darwinian.
No, no,
so,
no,
for
yeah.
example, and I believe that NASA's astrobiology program tried to offer an open-minded definition of life that was just self-replicating and capable of Darwinian evolution.
Yeah.
Yeah, yes. But interestingly, you changed it slightly, and I like that a lot.
I tried to
Because
simplify it.
Darwinian
It's really all you
evolution,
need.
to me, is too constricted.
Right.
Because, for example, suppose you have artificial life. And suppose even that it's sentient, you never know. It may be subject to non-Darwinian
It could be
evolution.
Lamarckian, right?
Exactly.
It doesn't have to
exactly.
follow,
It doesn't have
like,
to follow a Darwinian path.
Lamarck was this guy before Darwin who said things like, if throughout your lifetime you learn to run fast, then your offspring will also know how to run fast. That traits are directly passed, or not traits, but skills that you acquire actually during your lifetime. Now the interesting thing is with epigenetics, that's actually very much the case now. People have shown that recently. But this idea of other exotic kinds of evolution. So I like this idea of pitching ALife as a sort of experimental and theoretical complement to biology. That biology you want to think of as like one piece of the triangle, but there are these other two branches. Experimental biology is very new in terms of synthetic biology, and then this theoretical biology, which is kind of basically what ALife is.
Yeah,
Right?
for
Sort
sure.
of it's sort of a theoretical. So I thought we could talk. So Schrödinger had this very famous paper called "What Is Life," and this was before DNA was discovered, and he talked about this aperiodic crystal. He knew that we would have to have this pattern memory system that would be kind of like a crystal, but a crystal is boring. It's the same thing everyone ever knows. So to have a pattern, to have entropy, it would have to be aperiodic, so it would have to be non-uniform. And so he had this really awesome paper kind of establishing like the biology, almost this theoretical foot in physics, that to say that part of the questions that biology has are really closer to physics because they're so general and they're so sort of pervasive to the universe.
It's a great paper.
So
It's
yeah,
a-
it's really awesome.
Yeah.
So I thought we could kind of compare, you sort of start with Schrödinger, then bring up Fermi, and then we can bring up sort of both Goldilocks concepts.
Oh, yeah.
That the Goldilocks of the planets are rare, but really it's that our horse blinders are preventing us from seeing other kinds of life forms. So synthetic ALife has sort of like biological things, but then we also have experiments in the petri dish, and then we have like experiments in the computer chips. So we have sort of like the software, hardware, wetware breakdown. But then I try to think of like non-classical life. So classical life is all the stuff that biology studies. Non-classical life would be things that are kind of too exotic, that they're outside our horse blinders, so we've never really considered them as substrates for life, in a sense.
Would synthetic biology be considered non-classical or classical?
I would put it right now as is mostly being done as classical, in the sense that they're just trying to make life forms like we have it now. So here's the list I put together.
Can I share something with you?
Yeah.
Because you mentioned synthetic biology. My potential advisor at Northwestern, this is why I chose Northwestern, he's doing organic transistors for neuromorphic computing. And I felt like that had some overlap, so...
Totally. And so that's kind of like, halfway between the wetware and halfway through the hardware.
Yeah.
Right? So that's like almost like an overlap between those.
What about some kind of computational silicon?
Right. So I want to add that to the list. And just in general, exotic physics and exotic matter, can they support, non-classical life forms, as I want to call them?
You dropped a card. Someone did.
Supposed Ray just sent me the funniest thing. He put into chat, I think it was
Oh, I told him to send it to you.
Barbie Girl.
Yeah, isn't that hilarious?
And he did it as Quantum Girl.
I said they have to send that to you.
Make me spin, make me
I'll pull it up in a second.
shock, whatever you please. I can act like a wave, I can be discreet. Jump in, entangled friend, let's do it again. Hit the town, pull around, let's go party. Oh my god, that's
Yeah,
so
this one.
awesome.
You got to put that in your book.
Yeah, it was this...
Come on, Quantum Girl. Oh, I
That's
love
awesome.
it.
And so that's the kind of stuff that I'm talking about. So, Susan, let me show you the list here of this sort of non-classical life forms. So the first one I put on there is just quantum life. That I think we want to distinguish between the non-local, but also just sort of quantum mechanical,
Okay.
right? So here's sort of the list of, I think we can, and then I think we can flesh out what each might mean. So the quantum mechanical life would be a life form that operates fundamentally in a quantum mechanical realm, interacting with in a quantum domain. There's an interesting paper I want to tie in called quantum robots, and I think they've actually done some really great work in that space that we can they were looking at it from a technology point of view, but I think it's fascinating just to put it in like, wait, well, maybe there's natural quantum robots in a sense. And they defined them as a quantum system, like the robot's internal states are quantum, and the environment it interacts with is quantum.
Oh man, that's
So it's super cool.
interesting.
And then I want to coin like solid state life as just something that lives in silicon, right? That we think of life as being wet and warm and moving parts and all that, but it doesn't have to be, right? These GTP chatbots are eventually going to live in solid state. They're not going to have any moving parts. And so have a mind where when they say solid state, that means the only moving parts are subatomic. And so to have a solid state intelligence would mean the only moving parts are subatomic. So what would its signatures look like at that point? All right, we would have to ask the solid state physicists like what that might look like. Then I have distributed life. So we think of life as existing as a unified sort of bubble, and I'm me or whatever. But when we think of like bees or ants, but even more than that, because that's kind of like they're sort of like multicellular swarm kind of level. But what if and again, I think a cell might be a good metaphor for this. Like if you were to zoom in on parts of the cell, it doesn't even know it's inside a cell. It's just in this blur of chemicals. It's just trying to figure out. So if the cell is very distributed from a computer processing kind of view, they say that there's at least 5 million molecules in every cell, at least 5 million different chemicals, and they're all interacting with each other. And so how
is that even different than a swarm of bees
Exactly.
or even a swarm of drones?
Right.
I know.
And to say, and one thing that was fascinating, I learned in the neuro program, and I talked to a lot of neuroscientists, they don't really know this. When we think of the neuron, right, and we can think of it as extensions, and then at the end it has sort of these listening bits where it's talking to the other, right, the synaptic cleft where it's communicating. And then you have these proteins, the ion channels, that are sitting there waiting for the neurotransmitters to come across. Those proteins receptors, they're not glued to the end of the cell. They float all over that cell. Now, if you if you look at them, it's most likely you'll find them at the ends, right, in the boutons and the synaptic, in the dendrites kind of thing. But they don't have to live there. The surface of the cell is like this phospholipid raft, and they think it's like a jelly, and that the organelles that are sticking outside the cells, they're like moving around, kind of like a beach ball at a concert, and everybody's just like bopping the beach ball, and it kind of moves around. That these organelles, like the cell itself is very dynamic. And even like the morphogenesis of it,
You see organelles?
Yeah, the organelles, like the synaptic stuff.
Yeah, the AI organs?
Yeah, that they're well, like the little pieces. Let me pull it up. They're called lipid rafts.
So they
Oh,
have
Claudius,
like an
hey,
objective?
we're trying to solve the Fermi paradox with the solution that involves life that's the most advanced and is artificial, like AI, lives in higher dimensional space. So along the lines of like a string theoretic solution to the tension between quantum mechanics and relativity, where you have underneath each particle all these extra layers, and I was saying that it's an advantage computationally to have those extra dimensions to your computations. And then
That's the levels that we're talking about.
Yeah, there you go.
Oh,
all the way
shit.
up to the multiverse, right?
That's right.
All the way up
So
to the multiverse.
we're trying to explain non-locality from the vantage point, and we were talking about flat land, right? Which is a situation like, it's a book, an old book by Edwin Abbott, where you have 2D creatures, and I was saying they'd live on this piece of paper and they wouldn't have that added pop-out dimension, so they would have only a very limited capacity of understanding the room that they're situated in, and similarly we would have a limited capacity, but in form of life that was in a higher dimensional universe would not only have a greater capacity to understand us, but the rest of the universe, and maybe special causal powers in our universe. Like I can stick my finger in this piece of paper and really mess with the flatlanders, right? And it's because I'm coming in from outside. And we were saying non-locality is a manifestation of that principle. And so we're using non-locality as evidence for higher dimensional alien beings. Nice.
So now
That
we're
ought to get lots of press.
so now we're looking at like all these different exotic physics that might support life forms we would never even recognize as being alive.
Yeah.
And we're talking about how like cells are really distributed. So here's these rafts, right? So here's these cell walls, cell membrane, and then these sort of active pieces, these proteins that are communicating inside and outside. They are not glued in one spot. They are moving around like crowd surfers at a concert. You know, you're like this, and then people are kind of bouncing you around. And so the cell itself is very distributed and dynamic than what we normally think of it. Yeah.
Oh, wait. Oh, I didn't see my bad. Go ahead.
Have you thought about the possibility that the aliens might make their own space? Like, if you know, like the TARDIS in Doctor Who.
Right. I was going to mention that earlier.
Yeah. Also,
I like that idea.
they could potentially fill it with like some kind of exotic matter, which would have negative energy density, which could result in the space having negative curvature. And the thing about negative curvature is like unlike flat space, where like as you go out like farther and farther, it like increases with r squared. It can increase with like higher like coefficients than 2. So you could, in theory, in a relatively small region of space, have
A ton of stuff happening.
Yeah.
There's an interesting, in Stargate, they try to trap the replicator aliens in this time dilation bubble for precisely that kind of thing. They sort of want to keep them in this bubble of a different kind of space-time in a sense.
Oh man, that's so
Pretty
fascinating.
wild.
I was just going to say, when you talk about the receptors and all the different chemicals like that are very specific to certain receptors, it's the same way with us. We're only perceiving certain information, like light,
Exactly.
sound waves.
So that's what we're looking at.
That's
So
what you were
the horse
mentioning.
blinders of our perception.
Yeah.
So, like the aliens, whatever you're talking about,
It could be
they
right
might
here. Yeah.
might be communicating via ultraviolet something or something
Exactly.
that can
I
even.
mean, in the language of the debates at NASA with astrobiology, it's called the N=1 problem, which is that we're only looking for life within the confines of our own theory of life,
Right.
as mid-sized beings with DNA and whatnot. And we are not able to understand all the other possibilities, but the laws of physics and the laws of mathematics, if you will, the axioms of the mathematical system you're using, can give you a greater understanding
we have-
of
we-
life
like-
than just what we have, which is this sort of Euclidean space
And
understanding.
it's so dependent on our time and space scale. I was just watching a
Yeah.
talk recently, and they said if we were the size of a planet, we would perceive relativity. You know, it would take time, a finite amount of time, or light, rather, to get across, and we would sort of notice that. As humans at this scale, light happens so fast at the time we think in that we just think, oh, it's just instantaneous.
Oh, yeah.
So we don't even get to see that huge phenomenon, which is like a big deal in the world.
Also, if you were bigger, time would definitely pass slower because it would take more time for the information to move across your mind.
Right,
Essentially.
right. So Susan's been talking about this non-local light.
Sure. And that is a real issue with conscious life at a grand scale. Like if you had, a system that contained both, say, a computronium the size of Earth here and one on Alpha Centauri, it would be an 8-year round trip. So there's no way that system, if it was a singular system, could be a conscious one.
Well, I don't know though, because at a cultural scale, think about it. You know, people waited 20 years for the Star Wars to come back out again after the first 3. So as a culture, people are willing to wait a couple decades to have an answer.
Every thought would be so slow.
Yeah, but
right. If you were like trying to think, it would be like 8 years before you could have that next conscious step.
So I have an idea for the opposite of that.
It doesn't necessarily mean that it can't happen. It would just mean that like they would perceive the universe going by in a blur, essentially.
Oh yeah. But how would? Well, maybe
So-
planetary life forms exist, and maybe it's just that they're at a different scale.
I think it's exactly
I mean,
what it
it
is.
wasn't until we stuck that slime mold under a camera and time-lapse photography caught the fact that it was capable of navigating complex mazes, and we were like, what? It's intelligent in a sense. The slime mold can solve difficult spatial navigation problems. Isn't that crazy?
But I think the ancient world would have been very obvious to them that nature was intelligent. That even the most basic fundamental aspects of nature, sort of the dirt itself, they would have seen it as intelligent. I think the Greeks were way ahead with Gaia. You know, I've been trying to put together this artificial Gaia intelligence because I think it's really the whole planet that's waking up, and we want to think about what does a planet scale intelligence look like? Does it then perceive relativity? Can it perceive the folding and bending of space because it's on the scale that it's relevant to it in that sense?
Oh, that's so interesting. You know, the astrobiologists, there are some Gaia advocates, but they're thinking more of environmental issues, and
Right,
not
right.
sentient.
Yeah, I'm thinking-
perception. Yeah, I see what you're
Yeah.
thinking. Yeah.
So Gaia is the mother of Zeus in Greek mythology, and it was a sort of an archetype, a mythical Gaia, and it's the idea that the planet was alive. So in ancient times, the planet was worshipped as a being, as a mother goddess. This is where Mother Nature comes from. That concept that nature is a personified as a person, and. Oh, you know the tree? Yeah, I'm blanking on it. Right, Terra. Right? The Titan. Chronos. Yeah, was it like Chronos? Yeah, that makes sense. Yeah, that sounds right.
Chronos, yeah, of course.
Yeah. Go follow time kind of thing.
I was going to ask, can you overlap on what Michael brought up about the curvature? Like, well, the curvature being to represent, like, go ahead, Michael, yeah.
Basically, you would be able to put like in a volume of space, like we might imagine there's like only this much space. But if you were to have like a bunch of negatively curved space, you could fit like way more space in there essentially. And I think it'd be a far more viable way to get like a something similar to a higher dimensional space than
Like the ultimate clown car, where you could fit the whole circus in the car.
Yes. Was there like, you had a reference for this?
For which part?
For the,
imagine like taking a TARDIS and Doctor Who,
Doctor
shoving
Who,
it,
yeah.
shoving it inside of another TARDIS, and then just keep like shoving
Are
it.
you familiar with this show?
Yeah.
There's like a phone booth, and inside there's a tube in there, right?
If space is like actually like analog and infinitely divisible, then you should actually be able to do something like this in theory. You should be able to create a metric like this, and like the energy conditions and stress energy tensor required for that. Like will probably require some exotic matter, but I think that's like
the
doable.
TARDIS and Doctor Who, can you show us?
It looks like a blue British police box thing on the outside.
So from the outside, it would look like a small phone booth, but on the inside, it's like a huge ship.
Yeah, it's a massive structure.
Yeah. So like, imagine you have something that looks like it's that big, and on the inside, it's a whole thing.
It's really just negative, yeah, the top is.
Right. So it's sort of an impossible space in that sense.
Non-Euclidean.
Right.
Exactly.
And if we're in a simulation, if we're in a digital environment, that's easy. You sort of make a level. You can squeeze a level inside of another level.
Oh yeah,
That's not that hard.
Like if it was a simulation, that'd be like easy to do on that scale.
All right. So then I have another one that I'm really excited about. That I just put together this when I was typing this list, Susan. I've been thinking about it for a while, but I kind of came up with a name for it. And that's the idea of ephemeral life. So we were talking about these life forms that are really sort of slow and long-lived, right? Something that lasts like the size of a planet or whatever, a billion years, a billion years. But what about a life form, an intelligent life form that was like, it just like came and went like that. But it's so smart that it was able to do a lot, like accomplish a whole lifetime in even like a fraction of a second. Femtoseconds or whatever. We don't understand what it might be capable of. I'm okay. Thank you. So this idea I want to coin it ephemeral life, right? Intelligent life that's very short-lived,
Well, that would suck.
right? Like almost like a cosmic particle. But imagine like in the sun, for example, right? It's this enormous thing, and its plasma supports life, right? There's so much of it that even if the thing kind of came together in sort of a brain for even just like a third of a second, but we've seen how much thinking these intelligent systems can do. And so I just think this idea that what if we have this was hard for physics for a while to pin down these events that were so transient, they just don't really exist
What about
in the
like a
classical world.
Boltzmann brain that only exists for
Exactly. That's kind of what I mean. Boltzmann brain inside of like the plasma of the sun, or just random space-time, or in some other system. But it's such a transient event, such a short-lived event, that classically we might not even think, it's noise in the data or something.
There's probably ephemeral life all over Earth.
Yeah.
In fact, I mean, like even the life of a fruit fly, don't they live just like a day or something small?
Yeah, but I almost mean like in the dream, like the dream of your dream, like that,
Yeah.
like
No,
just sort of very fleeting, but there's a lot of intelligent in that. I think humans,
Yeah.
we have fleeting concepts where what we think of in a quarter second, if you were to like pin that all down, would be like a lot of stuff. for most people.
Yeah.
Um,
In fact, if there's a philosopher, Derek Parfit, who believes that there's no such thing as a persisting self.
uh-huh. I like that too, the self-illusion, yeah.
Yeah, and so it could be that in each moment in time, there's literally a different self there.
Right.
And so we could actually instantiate that kind of a system.
Well, I think part of our life is ephemeral in that sense. That we're going through this, because every moment, you know, when you look at like a picture of like a 6-year-old kid or whatever that's grown up now, and you're like, that little kid doesn't exist anymore, right? That version of that person, it just doesn't exist. But isn't that true of us throughout the whole day? Wasn't there a version of you an hour ago that doesn't exist anymore?
It could be.
So then I threw photonic life on there. I think that one's a little bit well developed. But I want to talk about this path from halfway between ape to angel. I think one of the reasons, you know, Susan, you talked about this, that, you know, we need to be looking at radio signals, not pottery, shards. That the intelligent life is going to be operating, you know, if they're not made out of electromagnetism, they're going to be using electromagnetism for almost everything they do.
I want to talk about non-local life. I want to figure that one out.
Yeah, and then
Hey, Ruben.
And then I've just got a couple more here. Relativistic life. Imagine you had a twin paradox, where in some weird, reproductive strategy of this alien, it actually utilized the twin paradox as like for education. Imagine you make a twin of yourself. One of your copy goes out and studies the Galactic Encyclopedia for its life. It comes back as a gray-haired person, and then you're like 7 years old, and you're like, what should I do with my life? And it's like, well, I've lived that life, and here's what you should do. Right? So this would be a really fascinating kind of way of biology of transmitting knowledge, or could we think of a life form that somehow found relativity and utilized it somehow? Right? I don't know if anybody's ever asked that question before.
I don't know if that'd really be too useful for a creature.
Well, at least as useful as, binding or whatever. And then, just two more. I had chaotic life, right? We have this theory now, there's a newer branch of physics called chaos that looks random, right? This is the thing with technosignatures. But chaos is not. It's very predictable. If you know the rule, it's just deterministic. You can predict it perfectly. But someone from the outside would say, oh, this is just noise. And so if we're looking to say, is this an intelligent conversation coming from somewhere? Well, maybe we'd say, oh, it just looks noisy. But maybe to the inside system, it's not going to look noisy.
Oh, have you ever heard of like code golf thing where people like?
Oh, yeah, we're talking about this week.
Oh yeah.
Yeah.
So like where they make these custom like programming languages where
As
like
obscure as possible.
not as obscure as possible, but basically where like the default instruction by leaving everything blank does what the code is supposed to do, and like they basically like even kind of tailor a programming language for everything. So a set of like directions, depending on how you look at it, could maybe encode for like an intelligent creature, or just be like noisy gibberish. It's like how you actually receive the data. It's like you could make it so that you have a sign which displays the number 1, or you could maybe like scramble it, and so it just looks like gibberish to anyone else. But to someone who looks at it with an unscrambling thing,
Right.
that looks at a new perspective, it might actually look like it's a useful thing. And you can extend this over to computation, where like you could have imagine a billiard ball computer forming in a cloud of gas, which from the outside would probably look like absolutely nothing.
Right, exactly.
And it's actually doing from another perspective, it might be calculating like something extremely useful and intelligent.
So what's really interesting is, if you think about like listening for alien communication or something like that, well, what do we do with your radio? You're talking with your radio to the internet all the time on your mobile phone, right? But the thing we do that, we encrypt it. And what does encryption do? You make it look like noise as much as possible. So when we think we're getting just random noise from the universe, it could just be they encrypt our Wi-Fi signal.
Because we haven't thought about it.
It's discoverable, right? It's already saying you don't have to be from another country, right?
Yeah.
It was in the
Right, so somewhere else, right? Yeah.
So I was just filling Ruben in.
Good. And then I got two more things in the list.
Well, then let's get to the non-local life.
Okay, just one more. Mind life is sort of like the cellular automata kind of thing, that we need to think about words and ideas as proto-life forms. That when we think about the substrate of the mind, it supports entities that we would think of as living. That just like the forest supports critters and the game of life supports gliders, our mind is a rich enough environment that it supports what I've been calling spontaneities. So little things that operate sort of at least as proto-life. So I think we need to think about this Goldilocks perception of why we have these horse blinders, and we don't think of, just like we didn't think of physics broad enough with Newton, we had to go to Einstein. We don't think of life broad enough, and I think that's the sort of the answer to the Fermi paradox. And I put this idea of the quantum camouflage, that as these things get so sophisticated, you know, we have this arrogance to think we could spy on them. We could spy on the aliens. We would see them in their spaceships and all that. And it's like, no, they wouldn't. No, you wouldn't.
They could see us, but we couldn't see them.
Yeah.
But we might be able to detect them through the right theory of non-locality. So let's do that. Let's try to do that.
I think we could,
solution.
yeah, I think we could try to infer sort of what that would look like.
So let's try to articulate that, because then we're gonna get it all translated and out.
Yeah, we got a few more minutes on the
Is
battery.
it still on?
Yeah. Well, Susan was talking about non-local life.
Okay, so back to Flatland.
No, I was just trying to see like references for you because I want to like, read more.
Oh yeah, that's crazy.
Yeah.
Yeah.
But what if?
So okay, so suppose you've got a solution to quantum non-local principles, right? Where so you have this entanglement relationship. It's so weird. You can entangle two states, like you can do it right here, and then you can take one to Jupiter, and as long as the quantum system isn't disturbed, you can then basically you can do a measurement on your system, and you can instantaneously cause a reaction in the entangled system all the way on Jupiter, right? And nobody can figure out why, right? I mean, this is the most bizarre phenomenon in the world. Einstein called it spooky action at a distance. And now they're measuring the rate of entanglement, and it's faster than the speed of light, at least by 8 times. I mean, they're probably just going to keep upping it with every, experimental result. Isn't it crazy? It's wild, all right? Now, if you think about it though, okay, so there are different theories that are supposed to be explaining this. And earlier we were talking about string theory, right? We're talking about the current candidate for the theory of everything, right? And, there's a lot of controversy about whether it's right, but I guess, I'm just looking around to make sure I don't get offensive. The skinniest kid in fat camp. Am I allowed to say that in this day and age? Okay, so let's assume it's right. Something like that. Something like that's right. Well, then space and time are emergent properties. They are not fundamental to the nature of the universe. And that goes back to the idea that there could be other dimensions that are folded underneath every particle, right? So if I was an alien AI, if I was like if I could choose anywhere in the universe to park my computations, I would want to be in a higher dimensional universe because I would have more power in the lower dimensional universes, and I could compute all kinds of stuff in the lower dimensional universes that nobody else can compute. Back to Flatland, right?